All right, let's try another one here. I don't know, it's kind of hard to do we do when you're home and I'm here, but we can try. This is the weather map from March 5th, 2013. The date's down there at the bottom. A day that produced several very serious tornadoes. Where did they most likely occur? And what evidence makes you think so? So remember our pattern here is going to be to start with our argument or claim. Argument or go. Argument, claim. So our argument or claim is the answer to the question. So the question is, where did the tornadoes most likely occur? And what evidence makes you think so? So on here, your argument or your claim is simply the answer to the question, where do you think the tornadoes were most likely to occur? If you would, please pause, decide for yourself, what would your argument or claim be? And then I'll continue. So if you remember from our info about tornadoes, tornadoes tend to form where a warm front and a cold front hook together. And most of the time where they hook together, there's also an area of low pressure. And that gives you sort of a lot of the ingredients that go into making a tornado. So my argument or claim would be that the outbreak of tornadoes most likely occurred. Different ways you might answer that. If you know what states those are in, you could just simply answer like that. Most likely occurred in Kentucky. If you don't know what states those are, you could just describe what you see on the map. Most likely occurred where the warm and cold fronts are hooked, together in the east part of the U.S., something like that. And that would be an argument then. You just want to answer the question, where do you think they occurred? They probably occurred right here. Whoop, pen. It most likely occurred right here. And we just have to have some way of explaining that. So there's your argument. Next thing we want to tell our reader is evidence, which is what makes us think so. I need to pause while you write this down. I'm so sorry. This is what we do. So go ahead and start on your notes page for today with your argument or claim. Go ahead and pause here, write that down, and come back when you're ready. Okay, now let's head to evidence. And now our evidence is what makes us think so. And remember, this doesn't come from us. Evidence comes from the map. I see on the map. The map shows something very, very direct in that way. So the evidence that makes me think so, or I can just say I see in eastern Kentucky a cold front and warm front hooked together with low air pressure in the same area. I haven't interpreted that for them. I haven't even really mentioned a tornado. I don't see a tornado on the map, and that's important to mention too. Tornadoes are too small to see on maps. All we see is the ingredients, so to speak, for the tornado there. So go ahead and pause. That'll be your evidence. Go ahead and write that down and then pause when you're ready. So now we get to the biggie. Sometimes, in previous arguments from evidence, reasoning has been pretty short or not the part we focused on a ton. Now it really is, because reasoning here is explaining, why did those ingredients result in a tornado? Why does that set of ingredients bake that certain cake? And there's kind of a lot to say. We have to explain kind of the whole process of tornado formation there. So my reasoning is going to start something like in areas where there are two fronts, the air is moving in different directions already. I'm going to do a semicolon to master writer here. Two different motions already. The warm air mass is moving up, and the colder air mass is moving, I guess, kind of to the right. To the right. So if you imagine what we've got here, we've already got wind kind of moving, you know, the warm air is kind of moving in this direction. And the cold air, right where they hook together, is kind of moving in this direction. And you can kind of see we've already got the start of some swirling air, which you may even put in there. Those, you can add the drawing to your reasoning. I might leave that there for mine. Those moving masses already start the process of swirling air. That's kind of the first step to it is you got these two air masses and they're moving, you know, one's kind of moving here, one's kind of moving here, and you've already got that swirling motion happening in here where you've got different directions of wind moving in different directions. But I'm going to pause here, let you write that part. The next step, I'm going to probably have to erase this to make space for it. So go ahead and jot this down. Then we got to talk about the low pressure area too. That's what kind of seals the deal. All right. Additionally, the low air pressure in that exact area causes upward moving air to begin a convection current that moves wind in even more directions. So you imagine, this is kind of hard to show. Try to do it because explaining is what we're doing here, right? Erase. So now, in this area of low air pressure, you know, that's causing air to move up, making the storm. And remember, both of these upward moving air, they're going to be part of convection currents moving this way. And so now we've got air moving here and here, wind moving upward, and we already at the bottom had those air masses kind of moving, you know, here and here. And you can see that we've now got wind kind of moving in this direction, and we've kind of got wind moving in this direction. And we've got the ingredients necessary for a tornado. We've got wind moving in lots of ways. I'm going to leave that. That's pretty good. I'll just try to type around it for you if you want to have that. So now the air pressure is low enough for a storm, and wind is moving in a lot of different directions, and all of that wind sometimes organizes into a tornado. And that's what we've got. Really, it's just like we've got to know our stuff enough to say where the tornado is going to occur, know the things we see, be able to cite the evidence and say what ingredients are there, and then explain why they happen. So remember, just being able to explain how a tornado works was proficient. Being able to extend that into this argument from evidence was more. All right, we're going to do a you do together next on the next page.